Good morning, everyone. Okay, so have you got marks of say sessional exam? Have you got any subject marks? No. Okay.
No, ma'am.
Okay. Uh. Okay. Okay. It's okay. Maximum of you have scored 30 out of 30. How? Google. Okay. Let us share. In last class, we what we discuss about if irrigation efficiency, isn't it? Water conveyance efficiencies, and after that, let's see, water storage efficiencies, isn't it? Water distribution efficiency, consumptive use of efficiency. So all the efficiencies are important. Okay. So consumptive use of efficiency, it is the ratio of consumptive use of water to the water depleted from the root zone. Next, let us discuss about diversion headworks, diversion structures. So in this structure, we are going to discuss about impounding structures. Okay, Gravi- that means dams, diversion headworks, canals are different types of dams and weirs and barrages, etc. Okay, so what is impounding structure? Impounding structures, it is the structure or dam means a man-made device structure. It is impounding structure. It is a man-made device structure. Whether a dam across a water course or other structures or other structure outside a water course used or to be used to retain or store waters or other materials. Okay. The term includes all the dams that are 25 feet or greater than height, and all the dams that are 6 feet or greater than, that means small dam and bigger dams. And what do you mean by diversion network headwork? In any hydraulic structure which supplies water to the off-taking canal is called a headwork. A diversion headwork serves to divert required supply into the canal from the river. So, what is a canal? Canal is what? A tubular duct or artificial waterway which is constructed to convey the water from the river. Okay, so basically, it is a hydraulic structures canal. What is the purpose of diversion network? Why we require diversion network? It raises the water level in the river so that the commanded area can be increased. It regulates the intake of water into the canal. It controls the silt entry into the canal. It reduces fluctuations in the level of supply in the river. It stores water for tiding over small period or short supplies. Next, weir. It is a solid obstruction put across the river to raise its water level and divert the water into the canal. If a weir also stores water for tiding over a small period of short supplies. It can call as storage weir. What are the components of a diversion headwork? It has a barrage or weir, divide wall or divide gryan. Gryan means spar. Okay. So what is gryan? Suppose this is a river. Okay. This is upstream. This is a downstream. Do you understand what is upstream and downstream? Where the water originates and from where the water starts to flow, that is your upstream area, and to which it is flowing, that is your downstream. So to divert the water, we are constructing Gryan. Gryans are also called spar dike. Okay, we are constructing spar so that the water is what the bank erosion can be minimized. Okay, and a fish ladder, head sluice or canal head regulator, canal offtake, flood banks, river draining walks. Next, what is a dam? A dam is a hydraulic structure constructed across a river to store or to store the supply water for a longer duration and release it through design outlet. So I think all of you have seen them. So it is basically water storage reservoir, and in rainy season, in flood, where there is flood, it releases water. And types of dams. There are different types of dams. Types of dams based on material of construction. It may be rigid and non-rigid. That means it may be built with reinforcement or RCC. It may be RCC structure or it may be earthen. Okay, if it is earthen, it is non-rigid. Based on a structural behavior, it is gravity dam, arc dam, buttress dam, and embankment dam. And based on a function, storage dam, detention dam, diversion dam, and coffer dam. Based on hydraulic behavior, dams are classified as overflow dam and non-overflow dam. Suppose this this is a dam. Here this is the river. So here this part is used as a reservoir. Okay. In rain over when it is overflow, it will flow to the river. And if the water level is here, the reservoir water level is here, then it is non-overflow flow. It water level rises, it is overflow dam. Okay. So another these are the two classification. General types: solid gravity dam, masonry dam, concrete, steel or timber dam, arc dams, buttress dam, R dam, rock fill dam, combination of rock fill and arc. Okay. Let's see what is a gravity dam. So uh, today I am going to take. I am going to vaccinate. Okay. So I will take class another 10 to 15 minutes. I can take class. Okay. Have you taken vaccine, all of you? Take vaccine. Okay. Whenever is possible. In some states, it has lockdown, isn't it? Nagaland, I think, and Arunachal. Arunachal, I don't know about Arunachal. Okay. Gravity dam. A gravity dam is a structure so proportion that its own weight resists the forces exerted upon it. It requires little maintenance and it is most commonly used. A gravity dam has been identified as a structure which is designed in such a way that its own water resists the external force. This type of structure is most durable and solid and requires very less maintenance. Such dams are constructed of machinery or concrete. However, concrete gravity dams are preferred these days and mostly constructed. Generally, in across all the river, concrete dam is constructed. Okay, because uh, it has less maintenance. The line of the upstream face. Sure. The line of the upstream face or the line of crown of the dam, if the upstream face is sloping, it is taken as the reference line for layout purpose, etc., and it is known as the baseline of the gravity or the axis of the dam. When suitable conditions are available, such dams can be constructed up to a great heights. So let's see what are the components of a gravity dam. It is very, very important. Components of a gravity dams. Okay. The different components of a solid gravity dams are crest, freeboard, hill, toe, sluiceway, drainage gallery. So in the figure, you can see this is the upper part of a dam is called crest. Lower portion of the dam is toe. This is the gallery. This is the sluiceway. That means sluice gate is provided in this area. This portion is called hill. Okay. And this is the NWL maximum water level. This is the normal water level. This is the maximum water level. This is the normal water level. And in between maximum and minimum, there is a free board. Okay. And inside them, there is a spillway. Okay. So these are the main components of a gravity dam. Remember, the upper portion is crest, lower left, lower right portion is toe, lower left portion is right. This portion is gallery, sluice gate, maximum water level, minimum water level, and freeboard. Do you understand? Okay, here this is a cross section of a gravity dam. Here, this is the cross section of a concrete gravity dam. Okay, this portion is crest. This is the upstream phase. Upstream is always written as WS. This is the upstream phase. That means this is the reservoir. This is the reservoir. Okay, hydraulic height of a dam. This is this height from the base to the water level. It is called hydraulic height at the upstream level. This is the downstream phase, and generally downstream phase is denoted by ds. And from the crest level to the base level, it is known as structural height. And this is the toe. As I have already told you, this is the base portion, this is the heel, and there is a hydraulic height at the upstream level. Okay, that means the water is, this is the river level, this is the reservoir. In reservoir, always water is stored in reservoir part of a dam. Okay, so this is the reservoir part. In rainy season, and directly water is added to the river. Okay, so about gravity dam, it is clear. what are the parts, how water is flowing, and which is the river portion, which is the upstream portion, reservoir. Okay. Next, the definition of the different parts are given: hill, toe, abutment. So abutment means sides of the valley on which the structure of the dam rests. Galleries. Hill means contact with the ground on the upstream side. Toe, contact of the ground downstream side. Galleries, some room-like structure left within the dam for checking operation. So inside the dam, there is a room-like structure. Okay, to operate sluice, to operate uh, spillways, there is a room inside the galleries. This diversion tunnel. Tunnels are constructed for diverting water before the construction of dam. This helps in keeping the riverbed dry. Next is spillways. It is the arrangement near the top to release the excess water of reservoir to downstream side. Sluice way, an opening in the dam near the ground level. So another important point is forces acting on a gravity dam. In design purpose, we required what are the forces acting on a gravity dam. So the forces are first water force, water pressure will act, isn't it? Is if sorry, because dams are constructed across river and it is a hydraulic structure, so water pressure is definitely will be a factor, isn't it? Next is uplift pressure. Pressure due to earthquake forces, silt pressure, wave pressure, ice pressure, and stabilizing forces in the weight of the dam. That means self weight of the dam. There will be one weight of the dam, isn't it? That is the self weight of the dam. So these are the different forces. So today I will share by evening I will share the notes. Okay, last class notes and today's notes. What are the pressure forces, seismic forces acting up to advantage of disadvantages? Okay, after advantage and disadvantage, I will give you notes. So let me take the attendance. What is today's date? Today is 12, I think, isn't it? So, Tejvino Crow,
Yes, ma'am.
respond your roll calls. Present?
Yes, ma'am.
Yes, ma'am. Keo Honu Chotu,
Present, ma'am.
present. Okay. Next, Bemishal
Yes, present,
Debarma,
ma'am.
Merolin,
Present,
Merolin,
ma'am. Present, ma'am.
Oniam Nivia,
Present, ma'am.
Shanjam,
Present, ma'am.
Resila,
Present, ma'am.
And KJ Vito, absent. Wilson, Wilson
Yes, ma'am.
Debarma,
Yes, ma'am.
Kichu, Kichu, Jodha SM,
Yes, ma'am.
Benishan, Jodha present.
Yes, ma'am.
Okay,
Yes, present, ma'am.
okay. Benishan,
Yes, ma'am. Yes, ma'am.
Trice,
Yes,
Toksham,
ma'am. Yes, ma'am.
Deepak,
Yes, ma'am.
Gyani,
Present, ma'am.
Jason, Pranay Chakraborty, Kashi, Bengia,
Present, ma'am.
Rupasri. What happened to her? Madhusmita Haloy, Zamir,
Present, ma'am.
Madhusmita Haloy, are you present? Madhusmita, absent. Okay. Zamir present.
Present, ma'am.
Pokhoto, Pokhoto, absent. Kilitoli,
Present, ma'am.
Nupsimongla Zamir,
Present, ma'am.
Nupsimongla Zamir,
Present, ma'am.
present. Okay.
Yes.
Walushan Zamir,
Present, ma'am.
Kishan Sanambam,
Present, ma'am. Present, ma'am.
Margang Mayak, absent, I think. And Minging Partin,
Yes,
absent.
ma'am. Yes,
Oh,
ma'am.
present. Okay.
Yes, ma'am.
Omit, Omit, Fiba Loham Thaba, Fiba Lahun Thaba, Razu,
Present, ma'am.
Lenu Tamzen Ponginer,
Present, ma'am. Present.
Vikasohe, Likatagu.
Present, ma'am.
Next, Puri Tamik, absent. Mar, Margarite,
Present, ma'am. Present, ma'am.
Febina,
Yes, ma'am.
Toko Totu, oh sorry, Ingtipi, Jos, Nelin Ingtipi,
Yes, ma'am.
Ing, Jos, okay, present. Febina, present.
Yes, ma'am.
Christina Nopi,
Present, ma'am.
Toko Totu, absent. Nenu, Shevei Vikoto, no Nenu. Sevek to Nonu, absent. Nanu Padung, present.
Yes, ma'am.
Okay. So anyone left?
Ma'am, Vikaso is also present.
Where is he? Let me give
He
him to respond. Tell him to respond. Picasso, what? Where is name?
Ma'am 097.
This one.
097, ma'am.
Oh, your roll number is not here. Only names are here. Uh, Can you see your name here?
Serial number 34, ma'am.
Okay. Respond once again. Okay. Present. Okay, what happened? Okay. Thank you.
Thank you, ma'am.